So continuing my exploration of GraphicsMagick in Lucee CFML, I wanted to take a look at something called a histogram. A histogram showcases the distribution of colors within an image, and I wanted to see if I could use the histogram to pick out the dominant colors within a given source image. So what I have here is a number of images that I can choose from, and on the left I render the input image. On the right, I render a scaled down, color reduced image, and then below that, I output the top 50 dominant colors or the most frequently used colors within that scaled down image. So you can see here's Lucee on the beach, here's Lucee dressed up as a duck, another Lucee, and you can see we get pixelation here because I'm scaling it down and I'm reducing the colors. I scale down and reduce the colors to I scale it down to increase the speed of the color reduction and the histogram generation. Lucee dressed up as a reindeer for Christmas, and sleeping and staring, and so on and so forth. So let's take a quick look at the code to see what's going on. So GraphicsMagick can produce a histogram, and a histogram gets generated as a MIF file, or a magic image file format file. But in order to make this a little bit more interesting, I wanted to create this intermediary image, so we actually go through more steps than you would normally to generate the histogram, because I want to have that artifact that I can render here. So the first thing I do is I read in the image, and we're going to be using the convert operation to generate the histogram. I remove any transparency just to simplify the color space. I make sure that we're looking at the RGB colors. We're only using 8 bits of color depth. And then I'm going to scale it down to 75 pixels. And I'm going to remove dithering so that we remove any noise that gets generated based on the scaling. And again, I'm scaling it down so that we can decrease the time it takes to perform the color reduction as well as to generate the histogram. So in this case, I'm reducing from whatever the colors are in the image down to 50 colors. And GraphicsMagick uses a color quantization to do this. I don't have any idea what color quantization is or how it works, but there's a huge README about it on the GraphicsMagick page. I assume it's very mathematical. And then just to make the demo a little bit more interesting, I scale the image back up a little bit so that we can start to see the pixelation here in the image. Otherwise, this would just be 75 pixels wide. And that's going to generate our output image. Now we're going to then take the output image and use it to generate the histogram. So I'm dipping back into GraphicsMagick, again using convert. I'm reading in the output image, this is the intermediary one we just created, and I'm writing a histogram to this MIF file. Now the MIF file is crazy. If we open up a demo one, here we can see essentially in the comments of this file, it includes the frequency of the color, the RGB and alpha, though I don't have any alpha obviously, and the hex value. And if we scroll down, you can see that there's tens of thousands of colors in this original image, which is why we're doing the color reduction, so that we can use that color quantization to reduce the colors into something that's a bit more meaningful and human consumable. Right, I mean, this is massive here, right? If we look at if we just grab how many spaces there are, I have 49,000 matches for this number of spaces. So there's 49,000 colors in this particular image, which is nuts. So, but of course, our histogram is going to be only 50 colors. So once that MIF file is generated containing the histogram, we can then pluck out that comment using the identify, using dash format and %C, which means pluck out the comment, and that's going to be returned in the standard output. At this point, we're going to have this value here, this payload, in a string, and then we can just use simple string manipulation and some regular expression pattern matching to grab these. So essentially I'm going to take each one of these lines individually, so we're going to split the comment into individual lines, and then we're going to use regular expression pattern matching to grab the numbers, right? Because we always know that the line has the one number containing the count, another number containing the red channel, another number containing the green channel, and then another number containing the blue channel. So simply what we do, again, we break that up into an array. Then for each line, let's grab all of the matching numbers. We know that the first one's the count, then red, green, and blue. And then we can sort that based on the occurrence. So we want the highest occurring values, the highest occurring number of colors to be at the top, and then the lowest at the bottom, and so forth. And then if we jump down to the actual HTML, you can see that we're just looping over those colors and outputting them as with the background, right? And if we actually just look in our source here, we can see that these are all just background colors using the hex that's extracted from that histogram. Now, it should be clear that the histogram and the dominant colors of the image are not necessarily the same as the color palette of the image, right? If we look at this beach image with Lucee here, this hot pink, from a colors distribution standpoint, the hot pink is like the 25th color or something, right? The 25th most common color. So if you were to say, for example, try to create a palette using the top 10 most frequently used colors, all you would get are these blues and grays, or blues and beiges, right? But that doesn't really represent the color palette of the image. Almost certainly a color palette would include this pink, and that's because a color palette isn't just about frequency, it's about distance and difference, which is much more of a softer science, let's call it, than the color distribution. I think we can get there, but I think that's a whole different mathematical rabbit hole that I am not technically prepared to go down at this point. But anyway, I think it's just pretty cool what GraphicsMagick can do, and just continuing to see how I might be able to leverage it inside of Lucee CFML and Cold Fusion in general.